Okay, welcome back.
Welcome.
So let's start to the second part of our training session. Our next speaker officially is now Harald Thorwarth from the Holzenergiefachverband Baden-Württemberg, and he will tell us something about properties and different ash fractions and their challenges, the influence factors of ash formation, as well as utilization and disposal of ashes. And his presentation will have an add-on from the AEE INTEC that will be presented by Christian Ramerstorfer about handling and ash and logistics of ash. And please don't forget your questions concerning our last three presentations. We will include it to the discussion after Harald Thorwarth's presentation. So let's start, Harald Thorwarth.
Okay, thanks a lot for the introduction. The topic I was given is a rather huge topic, so Johanna Eickermann and I would try to put together some basic information, and we got a hint from Harald Schrammel and Christian to keep it short to fix the time, so I'll try to do that. And if there are further questions, please do not hesitate to contact us also after the meeting today, and we'll try to answer questions. So our main focus today will be ash and how to handle it. I'll start the presentation with some basics about fuel and combustion, which determines the ashes and the ash compositions. So I will talk about how ash is generated. I'll talk about which ashes do we get from the process, and how or why do ashes differ, and how can we use, or how can we use it today, or how could we use it in the future. Starting with the main factor influencing ashes and ash formation is the fuel. The fuel is in our case wood, which depends on the growth of the wood, which depends on the soil, air, and sun. So we get trees, and those trees do contain the whole periodic table of elements. Among those elements, we have elements we call major elements, which are contained in wood in concentrations higher than 1%, which is mainly carbon, with about 40 to 50 mass percent, which is oxygen, slightly lower, and which is hydrogen, while carbon and hydrogen are our combustible elements. We have so-called minor elements with lower concentrations. Those minor elements are, on the one hand side, nutrients, so the plant is taking them up because they need them to grow. So we usually find them in high concentrations in bark, or in leaves, or in needles, compared to the solid wood. Those minor elements, from a combustion point of view, are rather ash formation elements. So those minor elements do determine the ash, do determine the total amount of ash, and do determine the composition of ash. Besides those major and minor elements, we also know trace elements. Those are all the elements contained in wood in concentrations lower than 0.01%. Those elements are mainly also the heavy metals, and those heavy metals, sure, depending on the concentration, but those elements are also known as toxic elements, which is the reason why we are of concern if we talk about trace elements. So fuel is one decisive factor influencing ash formation. And the other factor is the plant itself, which is used in all cases. Okay, Joachim.
Joachim, do you hear us?
Okay, so he was not talking to me. Good. So we use the fuel to produce heat and eventually electricity. And to do so, we need to combust fuel. So we put the fuel into whatever kind of furnace, and to combust this fuel, we need air, which got a certain composition. So we feed the periodic table of elements with the fuel to this combustion process, and we feed also the combustion air. And what we get is, in all cases, a so-called boiler ash, which comes out directly out of the furnace, and we generate exhaust gas, which is containing CO2 from the combustion of carbon, but also SO2, nitrogen oxides, uncombusted or incomplete combusted CO. Also the particulate matter, which is the minor elements, the ash forming elements, and also the trace elements. So what is the reason why do some elements end up in the boiler ash and what some do end up in the exhaust gas, being fly ash or particulate matter? This is related to the combustion process, which is for solid fuels always comparable. So we have got in zone 1 a fuel. This fuel contains included and excluded minerals, which are mainly the minor elements, the ash forming elements, and they at some stage come to the flame zone, get heated up. So volatile elements evaporate, get into gas phase, and the rather low volatile elements, which are mainly char and mineral fragmentations, they stay in the grade zone and the grade ash and end up as rather coarse ash with rather larger particles. We've got other elements, they evaporate, and after evaporation during cooling of the flue gas after the furnace, we see all sorts of reactions, condensation, heterogeneous reaction. So those elements do partly end up in fly ash, or they end up in very fine ash, which is being formed downstream the furnace. So we do get different ash reactions, and this is partly dominated by the combustion process, which we do not want to go into more detail. So as I said before, we've got the plant process, and we do get a rather coarse ash, and we do get fly ash, which is contained in the flue gas. So probably in different countries to different extents, but in Germany we are very concerned about particulate matter emissions. On the one hand side in the mobility sector, but also in the stationary combustion sector. So we get continuously stricter emission limits, which is partially on European level as well. So we do need to separate ash from this flue gas. So to do so, we use different filter systems, and we remove the particulate matter, or the biggest shares of the particulate matter from the gas, so it's not being emitted with the clean gas. With the filter ash, we also take out of the gas a rather large amount of those trace elements, which are, as I said before, the toxic elements or the heavy metals that can be toxic. So keep in mind, with the particulate matter, depending on different heterogeneous and homogeneous reactions in the furnace, but also downstream the furnace, we remove trace elements with the particulate matter. So we get ash, which is mainly the minor elements, the ash-forming elements, or the nutrients, as for instance phosphorus. And this ash also contains those toxic elements. So the ash is a mixture of material that we could use for fertilizing purpose, but it also contains toxic elements or toxic metals which we have to dispose. So ash, on the one hand side, can or needs to be disposed, which is cost incentive, and it contradicts the goals of a circular economy. Circular economy with two directions. The one direction is to use this ash, which is mainly fertilizer material, as fertilizer to improve the quality of soil. So to do so, we need to reduce or to have low toxic metal concentrations. Those toxic metals are also partially valuable components. So what is not the case at the moment, but what would be a logical result of a discussion of circular economy would be to take out these toxic elements, which can also be valuable components, to use them separately. And we can also use ash as additive to construction materials. In Germany, and I think in many of your countries as well, both utilization ways or using ash as additive of construction material or as fertilizer or recover valuable components, all are regulated by law. In Germany, we do have different laws, for instance, the fertilizer ordinance, which regulates to which extent or to what concentrations we are allowed to use ashes as fertilizer. To show you some results from analysis from different plants, you can see here 4 different heating plants or heating power plants. So what you see here on the left in the upper corner, HPPA is a heat and power plant. Below HPPB is a heat and power plant, and the plant HPC and HPD are heating plants. So what you can see is we do have different sizes, and we do have different combustion processes, and we do get different ash fractions. So we always do get bottom ash in all 4 processes. And in the rather bigger processes, we do get in total 3 ash fractions. We do get the bottom ash, boiler ash or fly ash 1, and we do get fly ash 2, while in the smaller plants we do get a bottom ash and we do get a fly ash. The differences between those ashes are the particle sizes. So generally speaking, the bottom ash is rather coarse ash, which is separated at roughly combustion temperatures. And the further we get to the chimney, the temperature at which these ashes are separated are decreasing, and the particle sizes of those ashes are decreasing. Due to those 2 parameters, temperature and particle size, or average particle size, we do get in general higher trace element concentrations in the ashes separated closer to the chimney than in those ashes separated in the with the bottom ash. So this is the reason why we got or we can call those ashes in a different way. So bottom ashes, which is here green colored, which is all sorts of combustion chamber ash, may be used as fertilizers, while the fly ash, which is separated in the last filter unit, is mainly excluded from use, which needs to be disposed as waste. And the ashes in between, which is boiler, cyclone ash, might not be utilized possibly. So generally speaking, if we're using fresh untreated wood, if we don't use waste wood, we mainly can use bottom ash as fertilizer, and the ash out of the last filter unit needs to be disposed. Why is this the case? Here you can see concentrations of different elements. You can see arsenic, you can see cadmium, lead, nickel, and the last thallium, which are all regulated in the German fertilizer ordinance. And you can see a red line and a green line. Those are the two limits given in this ordinance. And now you've got three diagrams. In the uppermost diagram, you can see the concentrations of bottom ash. In the middle diagram, you can see the concentrations of fly ash, and in the lowest diagram, you can see the concentrations of fly ash 2, which is the ash out of the last filter unit. And what you can see is we see differences from element to element, and we see differences from plant to plant, but we can see what I've said before. Generally speaking, in the bottom ash, the trace elements, the toxic metals, are mainly in concentrations as low so that we can use those ashes as fertilizer. And the farther we go to the chimney, looking at fly ash 1 or fly ash 2, those or certain elements exceed the legal limits. So the ashes out of the last filter unit can't be used as fertilizer, and the fly ash 1, which is boiler ash out of the cyclone, might not be used depending on the fuel that is burned and on the combustion plant. So if we look at fly ash 1, we see in each case two concentrations, which is from the first and the second power plant, and you can see the ashes from this power plant A would be usable as fertilizer, while the ashes of power plant B wouldn't be usable, which is in those cases mainly depending on the fuel that is used, since those plants also combust shares of waste wood. So if you use natural wood and you want to make sure that you're compliant with the legal limits, you can use the bottom ash for fertilizer purposes, but not any of the fly ashes. So this is what you're allowed to do. The fertilizer element ordinance in Germany gives also a limit above which we are allowed to call material fertilizer. So what you see is the yellow lines at 100% are the concentrations this fertilizer ordinance requires to be called ash a fertilizer. And what you see is that the bottom ashes are mainly below this yellow line. We see nitrogen, which is expectable since nitrogen is evaporated during combustion mainly and ends up in the flue gas. It's not condensing, absorbing, whatever. So the nitrogen concentrations in ashes are expectedly low, but there are also phosphorus, sodium, and calcium concentrations, which are also below those regions where it would be officially called a fertilizer. So if we then look at fly ash 1 and fly ash 2, we see similar to the trace elements, the closer we get to the chimney, the higher the concentrations of the nutrients. So at the moment we can say, okay, the bottom ash is the ash which usually can be used due to low trace element concentrations, but in terms of nutrient concentration, the fly ash 2, which is the highly contaminated ash fraction, would also be most interesting in terms of nutrients. Finally, a rather general information, the highest amounts of ash are found in the bottom ash, and the fly ashes are rather low if we compare the shares of the ash input to where the ash material leaves the different plants. So this is what we wanted to show you. As introduced, the second part, giving some more practical aspects on ash utilization, will be given by Christian Ramerstorfer and Harald Thorwarth. So for our part, thank you for your attention, and if there are questions, we can speak later, or you just send us emails.
Yes, perfectly.
Very well.
All right. So thank you for handing over. I would like to continue with a short look more from a practical point of view on ash handling and logistics, and I will try to do it quick and clean, because although clean is a really good keyword, I think, when it comes to ashes handling. So the presentation is structured into 3 short sections. First, where ashes occur in a district heating plant. Then a short look on what plant technology is used for automatic discharge of ashes, and some concluding notes and recommendations regarding ash handling. So first, let's start with where the ashes occur in the plant. I just try to get my laser pointer here. Here you see a plant concept from the manufacturer Schmidt, with the fuel storage, then great furnace and the boiler, and in this case also an ESP, or could also be a backhouse filter for flue gas cleaning, and then flue gas would exit here and at the chimney. So where do the ashes occur then? Mainly the biggest fraction, as Harald Thorwarth already said, below the grate. So grate ash is an important topic. Then within the boiler, you can see here an automatic pulse jet cleaning system for periodic cleaning of the heat exchanger tubes. There we have fly ash. Then also in the multi-cyclone, which is the first stage for flue gas cleaning after the boiler, where fly ashes occur, more the coarse fly ash particles, and in this case these two fractions, or already three, great ash and fly ash from the boiler and from the multicyclone are discharged into one container. Then going further on, there's also a second fly ash fraction from the electrostatic precipitator or backhouse filter unit, which is then fine dust or fine fly ash. So now let's have a look more into detail regarding the plant technology that's used for automatic ash discharge. You can see here the boiler in a cross-sectional view, and there are push rods or moving floors used to discharge the ashes that fall down from the grate during combustion into a discharge channel here with screw conveyors. Also here we have screw conveyors for the further transport of the ashes into the container then. It is also possible at bigger plants that throw chain conveyors are used. You can see this here, the green devices which transport the ashes below an electrostatic precipitator here again into the containers then. So this are the three main technologies which are used for automatic ash discharge. And then already finally, I would like to give you some concluding notes or recommendations regarding ash handling. So first of all, pay attention. This is hot, dirty, and dusty. It's important to ensure air tightness for the whole de-ashing system, especially also for the container. You can see this here. Try to get really tight connections to the container. And then also regarding safety with handling of ashes containers, and for the staff that has to work with it. Usually, or often ash fractions are collected separately, so to have the possibility to use the different ash fractions further on, or dispose, for instance, the fine fractions from the electrostatic precipitators. Please watch out, transport and ash disposal utilizations are regulated by law, as we already heard, and recommendation for practical use is to try to get shortest possible distances between the point of discharge and the ash containers. As you can see this on the example here at the right side, this is done in the way that for a multicyclone here and an electrostatic precipitator again, that the ash is directly discharged into the containers below. So there is shortest possible distances, minimizing the issues that could occur due to clogging or pollution of the discharge channels and so on. Yes, and finally, please consider sufficient space for container handling also, and also for truck shunting, for if the bigger containers are used, because that is often something that is not really taken into account that much during the planning of district heating plant, maybe. So thank you from my side for that, and questions are welcome.
If there is no other question, I want to just mention something I wrote into the chat. Mr. Schopper made a very good presentation. What he said actually is that legal emission limits in Austria are not always sufficient. That's the minimum requirement, and depending on local boundary condition, they could be significantly lower. As he pointed out, you might need some calculations depending on the local situation there. On the other hand, I want to mention that biomass district heating plants usually have a very positive effect on their overall emission limit, depending on what kind of heating system you substitute. Especially in our target countries, we have a lot of standalone individual heating solutions with old boilers causing a lot of emissions. So if you take that into account in that overall calculations and considerations, they usually have a positive effect. It could be, of course, the other way around. If you have a natural gas grid and natural gas boilers which you substitute, then you have to take that into account.
So the problem is, the legal problem is that in our approval procedure, it's not allowed to calculate the substitution of all the small boilers you get away by this network, more or less. So that's really a problem, and that's really not satisfying, because sometimes you have 30, 40 or 50 small installations which emit much more and under worse conditions, like one solid power plant with a high chimney and so on. But that's not allowed in the approval procedure. So that's really a problem from the legislative side.
Mm-hmm. Yeah, thank you.
Maybe a quick question to Harald Thorwarth. What is actually done with biomass ashes in Germany or Baden-Württemberg at the moment? Are you aware of any cases where it is used as a fertilizer, or is it mainly disposal?
The boiler ashes, or the grade ashes, or how you would call it, out of the combustion chamber, they can be used together with chalk, calcium material, which is put into the forest. So it can be mixed if it's below the limits I've shown in the presentation. And within this framework, it is used in the forests, which is makes some sense to bring back the nutrients to where they come from. So yes, but the filter ashes, they are disposed being waste, mainly below the ground in some sort of coverings.